Let's talk about inductive and deductive arguments, or induction and deduction. All right, we had this argument last time. Several studies have demonstrated a link between executions and decreases in murder rates. Therefore, capital punishment deters crime. Let's suppose this woman over here makes this argument, and we ask the question, is the argument valid? If someone accepts statement 1 is true, must they also accept statement 2 is true? Now, this is something we didn't ask last time, not about this particular smaller sub-argument. The argument that capital punishment deters crime. So is it valid? Could somebody say, well, I agree that studies have demonstrated a link between executions and decrease in murder rates, but I still don't think it deters crime? Or are they being illogical to say that? The answer is, well, they sort of could say that it was not valid. They sort of could accept one without accepting two. They could say, I'll accept that several studies demonstrating a link makes it likely that 2 is true. As a matter of fact, the more studies there are to support one, the more likely it is for 2 to be true. But no number of studies can prove that 2 absolutely has to be true. The way that especially statistical studies work is this. You do like 100 studies, and some of them, just by sheer coincidence, come out the way you don't expect. So there's always a few that come out with really weird results, and then there's the vast majority that come out correctly. So if I want to prove something, it's always possible for me to go cherry pick the studies that specifically prove what I'm interested in and ignore all the others that seem to contradict it. And so just the fact that there's several studies that did demonstrate a link doesn't mean that there's a whole bunch of other studies that didn't. That there aren't a whole bunch of other studies that didn't. So somebody actually has some reason to be a little skeptical here. But the more studies there are and the better they've been done, and especially if they're different kinds of studies than statistical, there may be a pretty good reason to think that probably capital punishment does deter crime, but it never absolutely proves it. So here's the situation we've got. She says several studies have demonstrated a link between capital punishment and crime, and decreasing crime, and therefore it deters crime. And he can say, well, the more studies there are to support one, the more likely 2 is to be true. But no number of studies can prove that 2 absolutely has to be true, and she's got basically 3 options. One is she can just dispute that with him. She should say, no, you're wrong, it is valid, and those studies do prove 2 absolutely. But I think that's difficult to do, because I think he's sort of got a point. So the second thing she could do is she could just give up on that argument. She said, you're right, let me come up with a different argument that will prove 2 is absolutely true. And I'd rather not do that, because I don't think she has to go to that much of an extreme. I think in real life, what she would say is something like this. Well, sure, I can't prove that 2 absolutely has to be true, but here, look at all these studies. And they look through them all and say, do you agree that it's at least very likely that 2 is true? And he might say, yeah, I agree, it's quite likely. And she would say, well, that's enough. To prove my original point about capital punishment, all I need is to know that it's likely it'll be true. I don't need it to be absolutely certain. In other words, she's not making this argument. Several studies have demonstrated a link, therefore capital punishment absolutely deters crime. We should do whatever we can to deter crime, therefore absolutely we should use capital punishment. She's making this argument. Several studies have demonstrated this link, therefore capital punishment almost certainly deters crime. Maybe not, but almost certainly. We should do whatever we can to deter crime, and therefore we should almost certainly use capital punishment. The first argument is called a deductive argument because it's claiming certainty. If you accept the premises, the conclusion has to follow. The second one is called an inductive argument. It only claims likelihood. If you accept premise 1, it makes it likely that 2 is true. I mean, it's almost certainly true that capital punishment deters crime. And therefore, it's almost certainly, number 4, true that we should use capital punishment. So these are called inductive arguments. And a lot of times people use inductive arguments because that's all they really need. If we're trying to decide on policy, for example, or whether to have capital punishment, it's enough to know that something's almost certainly something we should use. You don't have to be absolutely certain. You just have to be certain enough to make decisions on it. So very often people don't need a deductive argument that claims certainty. They just need likelihood. So let's think about inductive arguments briefly. They claim likelihood, not certainty. They're based on usually accumulating evidence. So the more studies you get, the more convinced you become. The more cases you see, the more convinced you become. And on the other hand, contrary evidence would start to undermine it. If you had 5 studies that proved the link and then you had a study suddenly that didn't, that wouldn't disprove it completely, but it would sort of diminish your confidence in it. So there's like accumulating evidence on either side, and you're sort of going on the preponderance of the evidence. All scientific arguments are inductive, not deductive. Scientific arguments never make a claim to absolute certainty. They're making a claim to likelihood, to probability. Now, sometimes the probability is so incredibly high, the likelihood is so incredibly high that it's virtually certain. I mean, gravity we're pretty certain of. But technically speaking, science has only proven that it's extremely, 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 extremely likely that gravity works the way they say. But all scientific arguments are inductive by nature. Math arguments, by the way, are not. Mathematical arguments are completely deductive. But since scientific arguments are inductive, almost every argument that relies on a certain amount of data will be inductive to a certain degree. So rather than valid or invalid, with inductive arguments, it's better to talk about some other thing, because being valid would mean that the second thing has to be absolutely true if the first one is true, and that's never the case with inductive. And that would make it sound like they're bad arguments, but they're not. They're just a different case altogether. So usually the technical term is to say that arguments are warranted or unwarranted when they're deductive. We're just going to say they're strong or weak. So the question is not, is this inductive argument valid, but is it strong? Reasoning by analogy is at the heart of inductive reasoning, and we will cover that in Chapter 11, but let me say a little bit about it here. Let me give you an example. For a person to kill someone else is morally wrong. Capital punishment is the state killing someone else. Therefore, capital punishment is like a person killing someone. Therefore, capital punishment is morally wrong. This is an argument from analogy. It says, look, a person killing somebody else is morally wrong, and that's sort of what capital punishment is like. So if that's morally wrong and capital punishment is like it, then capital punishment is morally wrong. Here's a different one. Killing someone in self-defense is morally acceptable. Using capital punishment to deter murders is like killing someone in self-defense. So therefore, using capital punishment to deter murders is also likely to be morally acceptable. So this is another reasoning by analogy argument. Here's one that we already looked at. In these situations, sorry, the there shouldn't be there. In these situations, in these studies, or in the situations in these studies, and then you show all the studies, capital punishment to deter crime. The next time we use capital punishment will be like those previous situations, so probably it will deter crime then too. That's sort of what we were saying before when we decided that it probably deters crime. Or, I said science was induction. In these 100 experiments, suppose somebody says, the law of gravity followed the following formula. The next time we rely on the law of gravity, it'll be like the 100 experiments we've already seen, so probably it'll follow the same formula then too. So reasoning by analogy is used for all these different cases. We'll study argument from analogy in detail in Chapter 11 near the very end of the semester. And the other thing we'll study is some ways for inductive arguments to go wrong in Chapter 4 on informal fallacies. So if you think one of the arguments in your paper is inductive rather than deductive, say so, and then you don't show in that case whether it's valid or invalid, even though that's what I said in the outline for the paper. Instead, discuss how strong you think it is. And if we've gotten far enough for you to do it, then pay close attention to the possible fallacies that Chapter 4 talks about, and tell me whether you think there's any fallacy committed, because there's some fallacies in inductive arguments that show up a lot. You might have a deductive argument and decide that the best way to fix it is to make it recast as an inductive argument. You might say this would be a fine argument if it just wouldn't make such a strong claim, if it would just claim probability. So that's what you need to know about induction.